class. My name is Ben, and James is here with me as well.
What's up, Calc 2 classes on YouTubes?
And we're here to talk to you about calculus. Specifically, calculus used in computer science, because that's where we intend to make our careers. Now you may or may not know, but computer science is a really broad range of fields and different things that go in it. So where do we use calculus? James and I had to ask ourselves that question, and we narrowed our focus down onto one thing. That is software development, or specifically game development. Because games are always trying to model the real world, and we know that physics uses calculus techniques quite often, so we figured that was a good place to start. We got in touch with a man named Jeremy Green, who's a professor at Charlotte Technical Center, and he gave us a few pointers. So here's a clip from my interview talking about calculus being used in games.
Games are trying to simulate the real world in as simple terms as possible. So games are trying to do shortcuts to cut the corners to give the impression of real world things, right? So like, for instance, if I'm doing a physics simulation, right, I may use calculus in it, but I'm going to cut corners as much as possible to like round numbers or stuff like that, because computers can't do calculations on the fly as fast as they can do simple math or multiplication.
Right.
So you'll find that most games aren't using hardcore calculus.
Right.
Most games are doing, basic, easy math, really.
Right.
Now, you can still use calculus to do games, but you're going to end up having to specialize your program to take advantage of calculus. So, like, if it takes a long time to run the calculations, you got to know exactly how much of your processing power you allot to doing physics, to doing, say, cloth simulation or fluid simulation, or that's really where you're going to have the majority of your calculus stuff.
As you could see in the clips, and here in the interview, computer modeling is becoming more and more advanced, to the point where sometime in the future, when the processing power is there, and there's enough resources, we're going to be able to model these physics equations in real time and render them out. While Jeremy said that it's not possible today, and a lot of developers are cutting corners in order to allow more processing power to go to other points in games, we can look at things like AutoCAD or the car industry simulations for crashes, where they are putting the resources out. They are putting that amount of effort out to find those calculations as accurately as possible. And so while we're not running AutoCAD, James has installed a programming language called Python, which is going to outline for you guys a way to install a library that allows calculations from calculus to be performed. He's going to find some derivatives, and you're able to see how line by line and how the actual code would look to solve a calculus equations. So James, why don't you show him that now?
Hello, my name is James, and as Ben said, that I will be introducing this part of our project. This is our example problem that we found off a website called GitHub, and what this will do is find the velocity and acceleration function of this specific math problem. So I can run that right now. This doesn't take user input, it will just output the answer. So it might take a second, and there it goes. And you can see that the velocity is 0.4 t, acceleration derived is 0.4, and now we can get to our problem that we made that takes user input. This is specially tailored to our specific problem we made, and we tried to relate it somewhat to games. So in the problem we made, there's a position function, negative 4.9 multiplied by t to the power of 2 plus 300 times t. And then there's a mass of a projectile, and we're going to make that 50 grams. And then it's going to go over 2 seconds. We're going to measure the velocity and acceleration over 2 seconds. So you can find that our program has derived this for us from the position function we gave it. It has found that function, which is right here, and after 2 seconds it has also calculated the velocity in meters per second. It has also done the same thing for acceleration, and the force of the object on impact would be 490 newtons. Now, for argument's sake, because this is a program and not just a math problem, we have made this so that you could put in different values for the position function if that ever existed. So for example, I could put in t to the 5th. If I can type, there we go. T to the 5th, and please enter the mass of the projectile stated in the problem. So we're going to make this projectile really big. We're going to make it like a cannonball, make it like 1,000 grams. Enter the value for time. Go away, Windows. Please enter the value for time in seconds. We're going to make that 60. And ta-da, did it for us. And that's a lot of newtons. We'll not want to be hit by that. Okay, there is our math problem, and Ben will take it away from here.
As you can see in James' clip, we're using software development, or in the computer science industry, to model calculus and to use calculus in the program. Now that might be a very simplistic approach, but we can look things at the car industry or AutoCAD, where those simulations representing physics need to be done, and people in the computer science industry are using software and lines of code to represent that. So hopefully you guys found this interesting, and there's an example of how calculus is actually used in the computer science industry. And as always, have a great day.